here the next question in which we have to find the type and order of a given closed loop transfer function. Okay, now you can see we have given over here closed loop transfer function to a unity feedback system. अब इस पर्टिकुलर एग्जांपल में हमारे पास स्पेसिफिकली क्लोज लूप ट्रांसफर फंक्शन गिवन है. ओके, और हमको क्या फाइंड करना है, टाइप फाइंड करना है और ऑर्डर फाइंड करना है. तो अगर हम यहाँ पे केयरफुली देखें तो इस स्टैंडर्ड फॉर्म में हमारे पास जो रिप्रेजेंटेशन है वो किस फॉर्म में है, जीएस के फॉर्म में. एंड जीएस क्या रिप्रेजेंट करता है, ओपन लूप ट्रांसफर फंक्शन. ओके, जीएस रिप्रेजेंट्स व्हाट, अ ओपन लूप ट्रांसफर फंक्शन. So what we have to do, first we have to convert this particular closed loop transfer function into a open loop transfer function. Okay, first we have to convert CLTF to a OLTF. Okay, and it is specifically mentioned over here the unity feedback, that means the value of HS is equals to 1. Okay, so simply we have to find OLTF. And previously we have seen one expression in which we have represent CLTF equals to OLTF 1 plus OLTF. Since it is nothing mentioned over here whether it is a positive feedback or a negative feedback. Okay, so by default we are considering as a negative feedback, and for a negative feedback we have a positive sign over here. So CLTF is nothing but a OLTF divided by 1 plus OLTF. So from this expression I can find OLTF as nothing but a CLTF 1 minus CLTF. Okay, so if you rearrange the things you get a this particular expression. So now we have a expression over here which is nothing but a CLTF, and I can find OLTF by substituting this particular value over here. So now you can see we have 2s plus 5 and we have s5 plus 4s6 s cube plus s square plus 2s plus 5, and we have over here what, 1 minus 2s plus 5 s to the power 5 plus 4s to the power 4, 6s cube plus 7s square plus 2s plus 5. So now if I write a OLTF, we get expression as 2s plus 5, and over here if I use this expression to move over here, we have minus 2s minus 5 which is cancelled out from this point. Okay, and we got s to the power 5 plus 4s to the power 4, 6s cube plus 7s square. Okay, and from that particular expression, so this is nothing but a open loop transfer function which is a GS. Okay, so now you can see if I want to convert it into a standard form, what I have to do, I simply adjust the parameters required to compare with a standard form. But over here we have only asked the type and order of a system. Okay, so to find a type we need to look into the denominator segment of a equation, and from that you can see I can simply take a s square out of this particular polynomial, and I can represent as a s cube plus 4 s square plus 6s plus 7. Okay, so now you can see the type of this particular transfer function is nothing but a 2, and order is the highest power which is a 5. So the type 2 and order 5. Next numerical, if I can see, it is based on the transfer function. So now you can see we have given over here the impulse response of a unity feedback system. Okay, and it is given out to be ct time ct which is equals to minus t e to the power minus t plus 2 e to the power minus t. Now you have to find what the open loop transfer function. So we know very well the transfer function for this particular system is nothing but a Laplace transform of a impulse response. Okay, we have taken a second definition of a transfer function. Oh, I have written it wrongly over here. Impulse response. Okay, so now, and specifically it is mentioned the impulse response of a unity feedback. That means this is nothing but a closed loop transfer function. Okay, so if I find a Laplace transform of a CT, we can write it as a e to the power minus t plus 2 e to the power minus t. And now we know the Laplace transform is of this particular segment is nothing but a 1 by s plus 1 square. The minus sign is because of this particular thing, plus 2 e to the power minus t is represent as a 1 or 2 by s plus 1. Okay. Now if I rearrange the things, we get minus 1 plus 2 s plus 1 divided by s plus 1 square, or I can write it as 2s plus 1 divided by s plus 1 square. Okay, so now we have a transfer function over here which is also equals to closed loop transfer function. And now we know for calculation of open loop transfer function, we are again using the same expression of open loop transfer function which represent CLTF. OLTF is equals to CLTF divided by 1 minus CLTF, which we previously used over here. Okay, this same expression we are using. So now you can see if I substitute this particular value, 2s plus 1 divided by 1 minus 2s plus 1 divided by s plus 1 square. Okay, so if I write it in this manner, so no, s square plus 1 plus 2s, because of this minus we get minus 2s minus 1, and that would get cancelled out now. So we have open loop transfer function which is nothing but a 2s plus 1 divided by s square. Okay. So for this particular example, the open loop transfer function we have find out to be 2s plus 1 divided by s square. Okay. So now you can see how easily we can solve the numericals. If you do not remember this particular formula, okay, so you can simply find a transfer function, closed loop transfer function, and then you can simply compare with this particular thing. Okay, so this is a closed loop transfer function and you just substitute the value over here and find a GS. Okay, so this is a straightforward method, and if somehow you are not getting the particular expression, you can find in this particular thing. Okay. So one more numerical over here. So now you can see in this numerical it is given that the impulse response of a system is 5 e to the power minus 2t to produce the response of t e to the power minus 2t. So we have to find the input. Okay. So in the previous lecture, I have already told you if I find a impulse response. Okay. If the impulse response of a system is given, then the impulse response, that the Laplace transform of impulse response is equals to a system response. Okay. So the Laplace transform of a impulse response is nothing but a system response. So now you can see the impulse response of a system is already given over here. Okay, so we have one system. Okay, and the response is already given and we want to get a particular output. So this is a CS. We want this particular output out of the system response, which is this. Okay, so we have GS over here. Now we have to find a RS. So over here we have to find RS. So GS is nothing but a Laplace transform of 5 e to the power minus 2t. Okay, so if I solve this particular thing, we get 5 s plus 2. Okay, and CS is nothing but a Laplace transform of t e to the power minus 2t. Okay, and we can write it as a s plus 2 square. Okay, so now we can have a value GS and CS over here, and we need to evaluate RS. So we know CS is nothing but a GS times of RS. Okay, so this implies RS, which is equals to CS divided by GS. So I can simply write RS as 1 by S plus 2 square, okay, whole divided by GS, which is 5 divided by S plus 2. Okay, so the value is 1 by 5 S plus 2. Okay, so the value we have found is S plus 2 and S plus 2 over here is cancelled out. So we have this particular value. So if I write in a time domain format, I can write it as 1 by 5 e to the power minus 2t. Okay, so this is the input we have to apply to a system to get a this particular output. Okay, and the system transfer function is this. Now you can see the things we have discussed and how easily we can solve a numerical corresponding to all those concepts.